In this video, I'm going to show you how we can configure MPLS LDP in iOS XR. Actually, I'm not going to explain about the concept of MPLS LDP because I explained about it in previous videos. Here, we learn how we can configure the same LDP in iOS XR. As you can see, we have a simple scenario. In this simple scenario, we have 4 iOS XRV routers, and I configured IP addressing and also IGP, means Interior Gateway Protocol, as OSPF in this scenario. Because of that, now XRV1 or router 1 has connectivity to the XRV4 loopback. In each router, we have a loopback interface. Quad 1/32 in the router 1, Quad 2/32 in the router 2, and Quad 3/32 in the router 3, and finally Quad 4/32 in the router 4. Let me show you that we have connectivity between these loopbacks. Also, if you want, in router 1, you can use do show route to verify the routing table. The routing table of router 1 include Quad 1/32 as connected interface, Quad 2, Quad 3, and Quad 4, and we have connectivity to each of them. For example, to the Quad 4/32, you can use do ping Quad 4, and we have connectivity. All right, how we can configure LDP? You have the configuration of XRV1, XRV2, XRV3, and XRV4 for IP addressing and also for configuration of the IGP. This is for the XRV1 and this is the XRV2 configuration, XRV3 actually configuration, and XRV4. Okay, now I'm going to explain about the configuration of LDP itself. Again, we have two methods. The method 1 means configuration or enabling LDP directly on the interface. You need to configure, you need to go to the MPLS LDP mode, and then the first thing that you need to configure is MPLS LDP router ID. This is mandatory, you need to configure it, and after that only mention the interfaces that you want enable LDP on it. For example, in the router 1, we configure MPLS LDP, then router ID Quad 1, and then interface gigabit 0/0/0/0/0. That's it. And don't forget, you need to commit it. I can show you. In the router 1, okay, I'm going to use MPLS LDP. Until now, we don't have any configuration about the MPLS. MPLS LDP is the first command. We went to the router config LDP mode, and here I'm going to configure router ID. Okay, it means this is the router ID we configure for the LDP, actually router ID, and after that Quad 1. And you learn about the transport IP address, everything same is here. And after that, we configure only the name of interface that we want. Here we have only one interface gigabit 0/0/0. Okay, this is the physical interface that we want to enable actually MPLS or LDP on it. That's it. Here we can configure other parameters of the LDP for this interface, but it's not important for us now. Let me commit it. Okay, and after this, now you enable the LDP on the gigabit 0/0/0/0/0. If you want, you can monitor it with the do show MPLS LDP and then interface. As you can see, on interface gigabit 0/0/0/0/0, we enabled the LDP actually via config. Enabled via config LDP interface. That's it. But we don't have any LDP neighborship until now because we didn't configure the XRV2. Do show MPLS LDP neighbor. Okay, we don't have any neighborship. Okay, after configuration of XRV2, we will have LDP neighborship. Let's configure the XRV2 again with the same command, MPLS LDP and router ID Quad 2 and the name of interface that we have, interface gigabit 0/0/0, and after that the next interface is interface gigabit 0/0/0/1. Don't forget, you need to commit it. Okay, now here, do show MPLS LDP interface show us that we enabled the MPLS on both interface gigabit 0 and gigabit 1. And also do show MPLS LDP neighbor, okay, neighbor, show us that we have neighborship with this actually peer LDP identifier, MPLS LDP router ID, and then label space quad 1. And also here we have the information that we learned about them previously in the MPLS LDP configuration iOS. Okay, or you know that here we didn't configure the router 3 and router 4 until now. This is the first method that you can configure. The second method of configuration of LDP is same as iOS. You can enable it on the IGP. Okay, actually, if you have OSPF or ISIS, you can configure router OSPF PID or process ID, then MPLS LDP autoconfig. Or if you want, you can configure this command under the area, but this is globally enable LDP on all interfaces that IGP enabled on them. Maybe this method, okay, is a little more efficient method because in most cases we use OSPF or ISIS, and then we don't need to configure each interface again under the MPLS LDP. For example, if you configure with the first method and you have OSPF, under the OSPF you configure interfaces names, and again under the MPLS LDP you need to configure the same interfaces name. But here with this method, only you configure one time the interfaces name. But don't forget, again we need to configure MPLS LDP and router ID. Okay, it's very important to know. And after that, in router 3, I'm going to configure with this method. First, MPLS LDP, okay, then router ID quad 3 in this scenario. And after that, we can go to the router OSPF mode. Router OSPF, the process name of this scenario is lab. Okay, and here you configure the easy command MPLS LDP IGP or MPLS LDP autoconfig. Look at here, MPLS LDP autoconfig. That's it. And here we have MPLS LDP autoconfig. That's it. And after committing these commands, it means that on all interfaces that IGP or OSPF in this scenario, we have now LDP. We can check, do show MPLS. You know that in the router 3, the OSPF enabled on gigabit 1 and also gigabit 0. Do show MPLS LDP, okay, and then interface. It's easy to see that we configured the LDP on these two interfaces with, as you can see, IGP autoconfig. But in the previous routers, router 2 and router 3, we configured it with LDP interface configuration, okay? And now do show MPLS LDP neighbor show us that we have router 2 as a neighbor. And also in the router 2, now we have two neighbor. Do show MPLS LDP neighbor again. We have two neighbor, router 1 and router 3. Also in the router 4, let's configure the same method, MPLS LDP router ID. Okay, MPLS LDP router ID. Then we configure quad 4. And after that, router OSPF lab. And also don't forget, if you want, you can configure under the area 0. Area quad 0, it means that only on the interfaces of area quad 0, I want to enable LDP. Okay. And after that, MPLS LDP autoconfig. That's it. Okay. And commit it. Now do show MPLS, then LDP, then interface, show us that we enabled the MPLS LDP on the gigabit 0/0, okay, with IGP autoconfig method. Again here, do show MPLS LDP neighbor, MPLS LDP neighbor show us that we have neighborship with the LDP neighborship with the router tree. Okay. Also, if you want, like the iOS, check the LIB label information base or LFIB label forwarding information base, you can use the same commands. Show MPLS LDP binding. This is for the monitoring of the LIB. Easy. And after that, show MPLS forwarding table. This is for LFIB. We have the same table with the same actually fields. And then also you have the next option of configuration of other LDP parameters under the MPLS LDP. For example, you configure the router ID, means MPLS LDP router ID. You configure discovery hello hold time, discovery hello actually time, and then discovery targeted hello hold time, and discovery targeted hello actually interval. Also, if you want, you can configure hold time. I explained about them previously in the iOS section. Here only we learn about the commands. Actually, the concept is not important for us because we should know them. But you have the option of configuration of all of the MPLS LDP parameters under the MPLS LDP when you configure the MPLS LDP. Look at here, MPLS. And then LDP, okay. Under MPLS LDP, actually, we have these commands. Many commands that we can enable, we can configure them under the MPLS LDP. And this is the MPLS LDP configuration in iOS XR.